So today we're going to look at verifying identities, simplifying identities, and just kind of refreshing our memory on our identities. So let's look at here. So I've got cosine of x times tangent of x plus cotangent of x is equal to cosecant of x. So remember, we want to take the more complicated side and make it look like the less complicated side there. So tangent of x, remember, is sine over cosine. Cotangent is cosine over sine. I would get a common denominator in here. So to get a common denominator, this is going to have both of these. So this one is going to need a sine. So it's going to be a sine squared. The second one's going to need a cosine. So it's going to be cosine squared. And then it'll be all over cosine times sine. And then on the outside I'll have a cosine. Well, sine squared plus cosine squared is 1. So when I multiply this through, it'll be cosine of x over cosine of x times sine. So cosine over cosine will go away, so I'll be left with 1 over sine, which is just cosecant. Alright, let's look at the second one here. So I've got sine of theta plus cosine of theta, all of that squared, plus sine of theta minus cosine of theta, all of that squared is equal to 2. Okay, so more complicated side, make it look like the less complicated side. So when I multiply this sine theta plus cosine theta, all of that squared, it's going to be what? Sine squared theta plus 2 sine theta cosine theta plus cosine squared. So I'm just foiling it out. And then I'll do the same thing here. So it'll be a sine squared theta minus 2 sine theta cosine theta plus cosine squared theta. Sine squared plus cosine squared, so that's going to turn into a 1. Sine squared plus cosine squared is going to turn into a 1. And then what happens here? Those go away, so I'll be left with 1 plus 1, which is a 2. So verifying identities, remember we take more complicated to less complicated here. So I want to have y'all take a second and do these for me. Okay, so I've got 1 minus cosine of the double angle over sine of the double angle, shows that's tangent. So remember, tangent is sine over cosine, okay? So sine over cosine. So I'm going to change this cosine of a double angle into sine. So remember, it's going to be 1 minus, and then so this would be 1 minus 2 sine squared x. Sine of the double angle is 2 times sine of x cosine of x. Okay, so this is going to distribute inside of here, so I'm going to remove this parentheses and I'm going to distribute that negative, so that's going to turn into a positive right there. So my 1's are going to go away, and then I'm going to be left with 2 sine squared x over 2 sine x cosine x. What happens to your 2's? What happens to one of your sines? So you're going to be left with sine over cosine, which is just a tangent. Okay. Alright, so here, number 4, I've got cosine squared x minus sine squared x is equal to 2 cosine squared x minus a 1. All right, so I've got cosine squared and a sine squared over here, so I want it to just be in terms of cosine squared. So what if I went ahead and changed the sine squared into just a cosine? So by the Pythagorean identity, it would be 1 minus cosine squared. So this is going to be cosine squared minus 1 minus cosine squared. Distribute that negative, so I'm going to have cosine squared x minus a 1 plus a cosine squared x. So cosine squared plus cosine squared is 2 cosine squared. And there you go. Good deal. All right, let's look at here, number 5 here. So number 5 here, I've got secant of x minus cosine of x. I want to show that that's equal to sine x tangent of x. So here I've got two terms, and I want it to just be one term multiplied together. So I'm going to take still this left-hand side and make it look like this right-hand side over here. So secant of x is going to be what? 1 over cosine. And then I'm just going to have cosine of x, and this is just going to be over a 1. If I get a common denominator, I would multiply both of them by cosine, or just this one by cosine. So I'm going to have 1 minus cosine squared. 1 minus cosine squared is a sine squared, right, by the Pythagorean identity. So you'll have sine of x times sine of x, and then basically a cosine. So sine over cosine is a tangent, and then sine of x. So there we go. Okay. So for number 6 here, I want to simplify. So I want to just break it down as much as I can. So to simplify here, I would get a common denominator. So basically those two things multiply together. So I'm going to multiply this numerator by 1 minus cosine. I'm going to multiply this numerator by 1 plus a cosine. And then these two things would be multiplied by each other down here, right? So what happens to your cosines? Those go away, so you're going to be left with 1 plus a 1, which is a 2. When I multiply these out, the middle term will go away, so I'll be left with 1 minus a cosine squared. Well, 1 minus cosine squared is just a sine squared, so this will be 2 over sine squared. And then this would be, what, 2 times, because 1 over sine is cosecant, so this will be 2 times cosecant squared. So that's about as simplified as you can get there. So that would be the answer that I would be looking for. Good deal? All right, let's look here. So here for number 7, I've got cosine theta times tangent of theta, all of that squared. Well, what is tangent of theta? Tangent of theta is sine over cosine, right? So this is cosine. Cosines go away there, so I'm going to be left with sine of theta, all of that squared, which is just going to be sine squared theta. That's as simplified as you can get there. Okay, all right. Last one here says, what is the exact value for sine of 100 degrees, cosine of 130, minus cosine of 100 degrees times sine of 130? Well, there's a minus sign here. I've got sine and cosine together, cosine and sine together, and they're opposite angles. So this is going to be the difference of sines. So it's going to be sine of 100 minus the 130 degrees. So therefore, I can simplify this. So sine of 100 minus 130, so that's going to be sine of a negative 30 degrees. So remember, sine is odd, so this can be the same thing as a negative sine of 30 degrees. And negative sine of 30 degrees, or sine of 30 degrees is what, 1/2? So this will be a negative 1/2. Okay, so just make sure that we remember our identities. The most important ones are the ones that we have drilled into our brains as much as we could. Also know your sum and difference of angles and those double angles. So know those double angles and know the sum and difference. Those are the most important ones that we're going to go through for your final exam. Okay? All right, if you have any questions about verifying identities or simplifying identities, let me know.